Hello, today we study derivative and the tangent line problem. As we remember that in the very first lecture, we discussed about two problems that make precalculus and calculus different. One of them is the tangent line problem, right? Um, let's consider the following function y equal to f of x. Suppose that the graph looks like this, okay? So this is y equal to f of x. And you fix one point here, say that is x0, and you have another point right on the graph, and then that point just move along the graph. Okay, so we want to find the tangent line. The tangent line, that means the line, the straight line that is tangent to the graph of this function at x equal to x0. So in order to do that, we need one point and the slope, right? With one point, so the point is a given already, right? And we need to find the slope. But how to find the slope? So in order to find the slope, we need to consider some limit. Look at this. Suppose that this point has coordinate x and y, right? And then each time when you connect the given point A, suppose this is M, so I have AM, right? I of course can find the slope of the straight line passing through A and M. Is that correct? So I can find the slope easily. How? The slope of this angle, let's say phi, is just the tangent of this angle, right? So if M approaches A, means this point approaches x0. So that means this straight line just approaches the tangent line. And then you have the slope of the tangent line, right? So let me find the slope of the straight line passing through AM. I have the slope of the straight line passing through A, M, okay? That is tangent of phi, which is equal to, the tangent of this guy equal to this distance, right? Divided by this distance. But what is this? What is this? This is just delta y, right? Because you are in here. You are in here. Suppose this is x0 and y0. So you move, right, to the x and y. So you have, the y in here. So this distance is just delta y. Is that correct? That is the change in the function value. And this part is nothing but, delta x, which is equal to x minus x0, right? So I have tangent of phi equal to delta y divided by delta x, or I can write that is f of x 0 plus delta x minus f of x 0 divided by delta x. Is that correct? You see, and as we just talked about this, if you take the limit, right, when x approaches x0, you get the slope of the tangent line. So the slope of the tangent line is equal to limit of f of x0 plus delta x minus f of x0 over delta x. Since x approaches x0 means delta x approaches 0. You see, or we can write the limit in the following way: fx minus f of x0. Here we have x minus x0 when x approaches x0. Both limits are the same. And that gives us, the formula how to find the slope of the tangent line at some given point here. So now we see that we need to consider some limit, right? Some limit in here. And this value, this limit, if exists, this is called the derivative of the function f of x at x0. Okay, so if the limit exists at right here, if exists, then this is called the derivative of the function f(x) at x equal to x0 and denoted by f prime x0. Or I can write f prime x0 equal to limit of f of x minus f of x0 over x minus x0. X approaches x0, and that is also f of x0 plus delta x minus f of x0 divided by delta x when delta x approaches 0. So this is the definition of the slope of the tangent line at x0 and the definition of the derivative. Okay, you know, if you compare this formula with the first with the one we talk about, you know, instantaneous rate of change, right? So this is nothing but the rate of change. Why? Because on the top you have the rate of, you have the change, right, in the function value, and here you have the change in the variable. So that is the rate of change. But you know, when you consider the limit, this is instantaneous rate of change, right? You see, that is different to the average rate of change without the limit. This part is the average rate of change. So I think we discussed about that when we talk about, you know, the difference between calculus and pre-calculus. Let's consider the following example. Find the slope of the graph of the function f(x) equal to 2x minus 3 at x equal to 2. So we know the definition of the slope, right? We have the slope is equal to the limit when x approaches 2 f of x plus 2. No, I think f of x only, right? Minus f of 2 divided by x minus 2. So f of x is what? Is 2x minus 3, right? In order to find f of 2, you just need to plug 2 into the function, right? Minus 2 times 2 minus 3 in here, and then here you have x minus 2. X approaches 2. You simplify that, you get limit of 2x minus 3 minus 4 plus 3 divided by x minus 2. X approaches 2. So you simplify 3 with negative 3, and you have limit of 2x minus 4 over x minus 2. X approaches 2. Again, right, you factor the top, because when you plug x equal to 2 into the limit, you get 0 over 0. So this is equal to limit of 2x minus 2. Here we have x minus 2. X approaches 2. And you simplify x minus 2. You get 2. The slope is 2. Okay. So this is one way to get the slope if we use this formula. Okay. If you use this formula, yes, that way. Now let's show how to get the slope using this part, right? Okay, so since x equal to, this is the second method, we have x equal to 2, right? That is x0 actually in the formula. So delta x is x minus 2, right? Then I have the following one. The slope is equal to the limit of f of x plus delta x, right? Or in this case, not x plus delta x, but 2 plus delta x, okay? Minus f of 2, right? Divide by delta x when delta x approaches 0. You see, if you compare this formula with this one, look at this. Look at this one. In this case, x0 is equal to 2. Right? I just plug 2 into the formula. Okay, so I have limit of, in order to find f at 2 plus delta x. So, this is our fx, right? From here, I get f of 2 plus delta x is equal to 2 times 2 plus delta x minus 3. You just plug 2 plus delta x into the function. Means instead of x, you have 2 plus delta x. So that's why I have 2 times 2 plus delta x minus 3. Does that make sense? And then f2 is 2 times 2 minus 3, and that is 1, right? I might simplify this like I have 2 delta x minus 1. Okay, so I plug these two values into this formula. I have the limit of 2 delta x minus 1 divided by, I think I do something wrong in here. No, plus 1. Here should be plus 1, sorry. In here we have plus 1, okay? So I have plus 1 in here. And then I have delta x. Delta x approaches 0. You simplify 1, you have limit of 2 delta x divided by delta x when delta x approaches 0. Again, this is 2. Because delta x and delta x will be cancelled out. You see, you may use, the formula that you feel more comfortable with. Agree? But both are correct. Agree? Let's move to more complicated function. Example 2. Now they ask us to find the equation of the tangent line to the graph of the function y equal to x squared plus 1 at x equal to 0. Okay, so means x0 equal to 0. That's it. Again, we need to find a tangent line. That means we have to find the slope, right? Because we already have the point, right? X equal to 0. In order to find the y coordinate, it's pretty easy, right? So the solution, let's find the y coordinate, right? Okay, the y when x equal to 0 is 0 squared plus 1 equal to 1. So the point is 0 and 1. You see this? You just plug 0 into the function, right? And then we need to find the slope of the tangent line. So let's find the slope. We know that the slope is the limit of y, or I write f of x minus f of 0, because we are considering the function as 0, over x minus 0 when x approaches 0, right? Now that is the limit of f of x is x squared plus 1, right? What is f of 0? We already found f of 0 right here. That is 1, you see? So I just write minus 1 in here divided by x. X approaches 0. And we simplify 1 on the top. I have limit of x squared over x. X approaches 0. That is limit of x. X approaches 0 because I simplify 1x, right? I simplify 1x in here, okay? So this is just 0. That means The slope is 0, right? The slope is 0. We have the slope. We have 1 point, so we can write the equation. That is y minus y0 equal to m x minus x0, where m is the slope, right? So in this case, m is 0. I have y minus 1 because y0 is 1, you see? Equal to 0. So my equation is y equal to 1. Right? You know, it is pretty easy, right? That is not that difficult. Okay, so of course, that is not very convenient if each time we need to find the slope, because you know, you may consider the slope, you may consider tangent line at any point, not only at x equal to 0. So probably it would be wiser if we can find the general formula of the slope of the tangent line at some given point. How about that? So let's solve that problem, okay? Let's find the slope of the tangent line at x equal to x0, very general case, okay? So, and again, right, I know the slope is equal to the limit of f of x minus f of x0 divided by x minus x0 when x approaches x0. You see? You know, we just need to use the definition, right? And what is f of x? That is x squared plus 1, because, you know, that is the equation of our function, right? So what is f of x0? That is x0 squared plus 1, right? Instead of x, I have x0. And now I will plug these two functions into the formula, into the limit. I have limit of x squared plus 1 minus x0 squared plus 1 divided by x minus x0 when x approaches x0. On the top, you simplify 1, you get limit of x squared minus x0 squared divided by x minus x0 when x approaches x0. And we discussed such limits several times, right? Like when you plug x equal to x0 into the function, you get 0 over 0. So x0 is a common 0, right? That is the common 0. Then we can factor the top and the bottom. On the top, I have x minus x0 times x plus x0. In here, I have x minus x0. X approaches x0. And then you can simplify x minus x0. So you have limit of x plus x0 when x approaches x0. And that is x0 plus x0 equal to 2x0. So this is the general formula of the slope. Okay? If you go back to the previous example, when x equal to 0, you see, you just plug 0 into this formula. So when x0 equal to 0, the slope is equal to 2 times 0 equal to 0. You see? So, you know, that is the most important things in this chapter, right? You need to find the slope. But in this case, we discussed about that. That is what? That is the derivative. That is the derivative. So let me summarize, right? You have function y equal to x squared plus 1. The derivative of this function at any x is y prime equal to 2x. You see? And you can use this derivative to find the slope of the tangent line to the graph at any point. Okay? In this example, let's find the derivative of the function y equal to square root of x. Okay? So, again, we know the definition. Derivative, or let's use y prime, okay? Y prime equal to the limit of what? Of f of x minus f of x0 when x minus x0 in here and x approaches x0. Okay, that is the derivative at x equal to x0. So we just need to plug f of x and f of x0 into the function, into the limit. You have square root of x minus square root of x0 divided by x minus x0 when x approaches x0. We have, different ways to solve this limit. Okay, and of course, we have x and x0 should be greater than or equal to 0. So there is no doubt because, the square root of x is defined only at non-negative numbers. So, I may use this condition, right, for the following one, x minus x0. That is square root of x minus square root of x0 times square root of x plus square root of x0. In here, I use the identity a square minus b square equal to a minus b times a plus b. Then I can rewrite our limit as square root of x minus square root of x0 divided by square root of x minus square root of x0 times square root of x plus square root of x0, right? When x approaches x0. And then you might simplify x minus x0, you get limit of 1 over square root of x minus square root of x0, x approaches x0. And now here we have plus. Then you plug x0 into the function. So you get limit, you get 2, you get 1 over square root of x0 plus square root of x0, which is 1 over 2 times square root of x0. So what does it mean? That means the derivative of this function is equal to 1 over 2 square root of x. Of course, in this case, x is bigger than 0. You see? And if they ask you to find the equation of the tangent line at some point, for example, find an equation of the tangent line at x equal to, let's say, 2, right? Okay, 2, that's fine. Then you have the formula, you can find the slope, right? That is 1 over 2 square root of 2, that's it. And once you have slope, you can write the equation. Because, if you have the point x equal to 2, you might find the y is square root of 2, right? Then you can write the equation y minus y0 equal to m x minus x0. Then you have y minus square root of 2 equal to 1 over 2 square root of 2 x minus 2. Okay, you might simplify this. You can write y equal to 1 over 2 square root of 2 x minus 1 over square root of 2 plus square root of 2. All right, so that's how we can use derivative to write the equation of the tangent line. Or basically, that's how we can solve the tangent line problem. Okay. Before we finish this video, I would like to show you one more example. Because we have square root. Let's find the derivative of the following function. Phi f prime if f of x equal to 1 over x. How about this? So basically we are working with power functions, right? Let's say x squared, x to 1/2, and now we have x to -1. Okay, again, right, we need to use the definition. We don't have anything else. So the derivative at some point x0 is equal to limit of f of x minus f of x0 divided by x minus x0 when x approaches x0. Of course, you know, x0 should be different to 0 because the function is not defined as 0. So I just plug f of x and f of x0 into this limit. I have limit of 1 over x, that is f of x, right? F of x0 is 1 over x0, x minus x0, x approaches x0. So on the top, you know, I need to simplify that, right? I write here 1 over x minus 1 over x0 equal to x0 minus x divided by x0. Is that correct? You know, I just use cross multiplication, right? And then I have x0 minus x divided by x0 times x minus x0, because I divide this part by x minus x0. So I just, you know, write x minus x0 into the denominator, right? And here I have x approaches x0. And if you pay attention, on the top we have x0 minus x, and here we have x minus x0. So they are different only in the side, right? Then we may simplify that. We get limit of, on the top we have -1. In here I have x0, x approaches x0. Why -1? Because x0 minus x over x minus x0 is equal to -1. Then you plug x0 into this limit. You get limit of, no limit, sorry. You get -1 over x0 times x0, which is -1 over x0 squared. And this is the derivative of the function 1 over x at any x. So I can write here derivative of, let's write derivative of 1 over x equal to -1 over x squared. You see, it's pretty interesting, right? Or, you know, if you pay attention, I can write x to -1 derivative is equal to negative x to -2. Okay, sometimes this formula is also useful. You know, so we have derivative of some very basic power functions, right? Power function. In the next videos, we will learn more differentiation rules, and we will know the power rule, how to find the derivative. Okay, so I think we can finish this video right here. In this section, we still have one more topic, that is differentiability and continuity, but I just divided into a separate videos. Okay, I hope that the video is clear enough, and I repeat again, right? In this video, we use definition only. We only use definition, and don't forget that we have two formulas. Okay, two formulas of the derivative and the slope. So you need to remember that, you know, what does it mean derivative? Derivative is the rate of change, right? Instantaneous rate of change. That is the first thing. And at the same time, that is the slope of the tangent line, okay, to the graph at some given point. So, you know, sometimes they ask you different questions, but the solution sometimes are the same because, you know, derivative, slope, write the equation of the tangent line. Okay, so in this video, basically, we already solve the tangent line problem. All right, thank you, and see you in the next video.